Now, so far, in all of the reactions that we've looked at, they've all been various things combining with the oxygen gas and giving out energy. But in each case, we've needed to supply some energy to start the reaction. We've needed to either use a match or a candle, a flame, to start the reaction. Now, do we always need to supply some energy to start the reaction? Well, let's go back to our hydrogen. Remember the hydrogen in the bag? We showed that it was hydrogen. We squeezed some out of the bag here and lit it with a match. Well, this time, what I'm going to do is see if we can light it a slightly different way. And I have some metal catalyst here. This is palladium metal, very finely divided palladium metal. I'm going to put a little bit onto this cotton bud and hold this in the jet of hydrogen. So there are no flames, but I'm hoping that the hydrogen will actually light. Well, let's see what happens. Nothing. But keep watching. Squeeze harder, Mark. Ah, there we are. It did indeed catch light. So I can show this. It is burning. The flame is very difficult to see, but I can light a match in the flame that's now burning. There we are. So the hydrogen has caught light with no flames whatsoever. So this is using the very finely divided palladium metal catalyst. Now, catalysts are very important in our lives to help start all sorts of reactions. In fact, your car, if it's a new car, it will contain a catalytic converter. This is the catalytic converter from a car that we've chopped into two, and inside this are, well, there are two parts. These are the catalytic converters themselves. So again, they are very finely divided metals coated onto the surface of this sort of honeycomb center. And this helps any gases that hadn't burnt properly in the car before they come out into the air. It helps make sure that they do burn properly. So if there are any, for instance, carbon monoxide, which is very poisonous, this helps it to burn to form carbon dioxide. Okay, now we can show this with some hydrogen. Now, with this particular catalyst, we do need to sort of warm it up before it works well. So I have a hydrogen jet here. I'm just going to light the hydrogen. It's very difficult to see the hydrogen, but it is now lit. And I'm just going to warm up the catalyst. Now I've switched off the hydrogen. There's no flame. But watch what happens when I put this on the catalyst. So the catalyst is glowing red hot. And it's now lit the hydrogen. So again, no flame, onto the catalyst, glowing red hot, and it lights. Okay, so this catalyst here helps the reaction to take place. What happens, the hydrogen gas sticks onto the surface of the metal, the oxygen gas can stick onto the surface, and so they're coming right next to each other in just the right way to combine. And once they start combining, a lot of energy is released, so that's why you see the catalyst glowing red hot there as this energy is being released, and then eventually it lights the hydrogen itself. Now we have another metal catalyst here. This time it's platinum, and in the flask here we have methanol. It's an alcohol that burns. It's the same alcohol that we started with the coloured flames. We're just going to warm up the catalyst, the metal catalyst, the platinum here, and then lower it into the methanol vapor. And you should see, as this reaction takes place, the catalyst here will begin to glow. This is as the methanol and oxygen are coming into contact with the metal, and they're both beginning to react there, and this will heat up the catalyst, and it should glow red hot, I hope. Oh, there we are. It's beginning to glow, and any second now it will probably light the methanol vapor. There we are. I'll blow out the flame, and the whole process should start again. So again, the methanol vapor is rising over the catalyst, and it will glow red hot as the methanol and the oxygen come into contact with each other on the surface of the catalyst, glowing red hot. That's it. And again, it should light the methanol itself. And then it blows itself out, and it keeps repeating, which is really rather nice. OK, well, we better stop this because we don't want any unwanted flames. So let's just remove the catalyst, and Mark can deal with that.